Let's install VS Code on Ubuntu Linux. First of all, we're going to check and make sure that we've got a few tools installed on our machine. From the command prompt, we're going to run java -- version, and we see that we're running version 17, perfect for building a Spring Boot 3 application. We'll use Maven to build our project, so let's verify that we have Maven installed. We'll run mvn - version. We have version 3.6.3, which is fine. So we're ready to get started installing VS Code. Then to make sure everything works, we'll build and package a Spring Boot 3 RESTful application. Let's bring up a browser and search for VS Code. Let's click on Download. Notice we can install VS Code on Windows, Linux, or Mac. Debian packages are used for Ubuntu, and I'm running a VM on an Apple M1 chip, so I'll take the ARM64 download. Please select the appropriate package for your underlying hardware. When that's finished, let's cd into the downloads directory. We'll install the file from the command line. To do so, we'll run sudo dpkg -i and the name of the Debian file we downloaded. I'm prompted for my password. When the installation is finished, let's start up VS Code by simply running the command code. At this point, we've installed VS Code. Congratulations, you're all set. There are lots of customizations you can make. I left the screen in dark mode. Let me know in the comments below if you like videos recorded with the dark mode or if you prefer a light background. Let's go over to the list of icons on the left and select the one that looks like Tetris. This will open up the extensions page. Here we can add features and capabilities beyond what comes out of the box with VS Code. This is the real power of VS Code. There are tons of amazing extensions. On this first page, we're offered a list of popular extensions for development. Let's click on the search box and look for Java. Let's take the first option, Extension Pack for Java, and install that. Notice that it comes from Microsoft, so it's something we can trust. It installs some other components, including Java Debugger, Test Runner, Maven for Java, and an AI tool for auto-completion of your code. It's offering us a chance to install the JDK. However, we already verified that we had it installed before we started this process, so we're good. Now let's go back to the search box and type in Spring. We're given 4 options at the very top. The first 2 are from Microsoft, and the next 2 are from VMware. And if you didn't know, VMware is the creator and maintainer of Spring. Notice there are millions of downloads of these plugins, and they're available from reputable sources, Microsoft and VMware. So these plugins can be trusted. Let's install each one. The first extension from Microsoft will give us access to the Spring Initializr, which will allow us to generate a Spring Boot app in seconds. The other components will help us develop and debug Spring applications. Once the installation is done, let's click on Create New Project. And this will bring up Spring Initializr. It will walk us through each option of the app we'll generate. First, we'll select version 3.0.5 of Spring Boot. By the time you watch this video, the version may have changed, so my advice is always take the latest. Next, we'll use Java to build our app. I'll change our package name to be com.beginsecure. Next, we'll put in an artifact. We'll call it HW. You'll see why in just a moment. We're going to package our application as a jar. We'll need Java 17 or later for Spring Boot 3. We already verified that we have that, so let's choose 17. And for our list of dependencies, we're going to make this a RESTful web application, so let's search for web. We'll take the third option down, Spring Web. We can tell it's selected by the check mark next to the component name. When we're done selecting our dependencies, we'll press Enter and move on. Next, we're prompted for a location to save and generate the code that we're going to create. For this project, I'll simply select the Documents folder and click Generate into this folder. The HW directory will be created there that contains our project code. We get a message in the lower right corner that says the code was generated. Let's click Open, and we get a new VS Code window. We're prompted to see if we can trust this code, and we do, so let's go ahead and click Trust the authors of this code. We'll get several pop-up boxes in the lower right corner asking us if we'd like to install a plugin or collect data. I'll accept most of these and we'll just move along, but do what you wish for your project. Let's click on Check Details to see what's going on behind the scenes. We can see that Maven is importing our dependencies, our class path is being set, and some other initialization activities are taking place. We're prompted to add null analysis to our project. This will alert us if we create code that throws a null pointer at runtime. It's certainly something we want, so let's go ahead and enable that. Another pop-up about Java source reconciliation. Sure, sounds good. And over on the Explore panel, let's drill into our project. We'll click on our source, main, Java. We see our package name, com.beginsecure. Let's click on the name of the application, HW application. It's a very simple but correct main method that we can use to drive our Spring Boot application. It has the Spring Boot application annotation that enables all the Spring Boot magic. There's nothing under static, nothing under template, and application.properties is empty. Let's go ahead and click on test and HW application tests. We see there's an empty test that was generated for our application. Great, so at this point we have a very simple Spring application all set up and ready to use. Now let's do something to make it more interesting. Let's go back to the HW directory, right-click and select New Folder. We'll give our folder a name of controllers, and let's right-click on controllers and select New File. Then we'll call the new file hwcontroller.java. In our code window, we're prompted to see if this is going to be a class or interface. We'll select class. This will be a REST controller, so let's go ahead and annotate it with @RESTcontroller. This annotation does a lot of nice things. Among them, it makes the response from our endpoints return objects as an HTTP response. Notice our import statement is set up correctly. Now we'll create one method in our class. It'll be public. It will return a string, and we'll call our method HWMessage. It will take no arguments. We'll add curly braces around it, and then we'll simply return the string hello world. And let's annotate our method with @getMapping. And we'll give it an endpoint. In quotes, we'll put in /API/HW, and that's it. Now we have a RESTful application ready to be deployed. In the top right corner, we'll click the Run button, and we're prompted for the file name that we want to run. Our main execution point in our code is HW application, so let's select that. And here we go. More pop-ups. All right, more pop-ups. We'll enable the actuator for this test app. We provide some endpoints for monitoring the health of the application, but be careful using this in production. You'll want to lock this down. More pop-ups. Okay, let's skip some of these. Our app is running, so let's test our endpoint. We'll open up a browser in a new tab, and we'll go to localhost :8080/API/HW, and there we go. We see our message, hello world. Now let's see how we can package our application into an executable jar. Over in the Explorer window, let's drill in under Maven, and we'll drill into our project. Let's pull that window up a little more so we can see it. And let's click on Lifecycle, and then let's select Package and click the arrow to the right. And what this will do is package our application as an executable jar file. The result will be written to our target directory. So let's go into the terminal, type ls, we see our target directory. So let's cd into the target directory, run ls once again, and we see our snapshot.jar file. So let's run that. We'll type in java-jar hw001 snapshot.jar. It starts up, no errors, good. This time, rather than running it with a browser, let's use the curl command. Let's open a terminal, and we'll type in curl space localhost :8080/API/HW and press enter. And we get back our message, hello world. All right, that's it. We installed VS Code on an Ubuntu Linux machine, installed a bunch of Spring extensions, and built a simple RESTful web application. Great job. Let me know in the comments what plugins you use in your installation of VS Code. Thanks for watching, and remember to always begin secure.